Dear students, I hope after watching those videos you are more lines are zero point 0.1 centimeter or 1 millimeter. What you have here is obviously 13.3, but since you are estimating to the next digit, the correct answer is 13.30. How about this one? So we can see it's past 12.8, is between 12. So there are some rules involved. These are very simple. What do you read in this graduated cylinder? Well, simply you have passed 55 and you are right on the 56. Your reading is 56, but your accuracy is actually 0.1. So the new estimate, the last digit, this one, you have between 53 and 54. So your reading. Rule number 1, very simple and straightforward. All non-zero figures or digits are significant figures. There is no need to have any doubt. If it's non-zero, it is a significant figure. For example, how many significant figures do we have here? 3. How many do we have here? Obviously 5. And yes, you guessed correctly, 4 significant figure. Rule number 2, all zeros between significant digits or any non-zero digits are always significant. This is also very simple and straightforward. For example, the 0 is a significant figure because it's between 2 non-zero digits. How many significant figures do we have? 3. How about this one? All 3 zeros are significant because they are between 2 non-zero digits. Answer is 5. And last, we have 0, the right side of decimal, but it's between non-zero digits. The answer is 4. Rule number 3. All final zeros on the right side of the decimal are significant, assuming the left side are non-zero. Let me give an example here. So obviously, we have a decimal here, and this 0 here is on the right side of the decimal, and here we have non-zero. So therefore, this is significant, and the answer is 3. Well, same thing. These 3 are on the right side of the decimal, and we have non-zero here, then we have 5. Last but not least, based on rule number 2, this and these 2 are already not significant figure. They are not leading 0. So and this one, which is the right side of the decimal, and here is non-zero, is also significant. In total, we have 7 significant figures. Rule number 4. All zeros that act as placeholders are not significant. Another terminology is the leading 0. So in a sense, if we have examples, how many significant figures do we have here? Let me go. So we have some zeros here. Obviously, these 3 zeros are on the right side of the decimal, but here is 0. None of these zeros consider significant figure, so the answer is 1 significant figure, which is only the number 2. Here we have 3 significant figures, and then of course 23 0 in front of them. So in total we have 3 significant figures. This is another one, so it's kind of confusing, but let's see. So there's a decimal here. These three are significant figure because they are the right side of a non-zero. So if these three are significant figure, therefore these two will become significant figure because they are between two sets of significant figures. So the answer is 6. And last but not least, here we have these these 4 zeros. These are not significant because they are not the right side of the decimal, and they are not between one side we have digit, but in this side we don't have any digit. Therefore these are leading 0. We have 2 significant figure. Rule number 5. All counting numbers and constant they have infinite number of significant digits. Let's go over a few examples. How many significant digits are in the following examples? Well, the first one, we have 3 leading zeros. They don't count. So the answer is 2 significant figures. How many significant figures do we have here? All the digits here are significant figures based on rule number 2 and 3. We have 2 significant figures based on rule number 4, that these 2 zeros are leading zeros. 3 significant figures we have here. All 4 digits, including the last 2 zeros, are significant. 1 significant figure. And last but not least, all the digits are significant figures. Let's talk about rounding rules. Rule number 1, if the digit to the immediate right of the last significant digit is less than 5, we don't round it up to the last significant digit. For example, 43.82. So if we need to get 3 significant digits, in this case, we simply cross the 2, and the answer would be 43.8. So therefore, that 2 doesn't count. Rule number 2 of rounding. If the digit to the immediate right of the last significant figure is greater than 5, we round it up. For example, 234.87, if we need 4 significant digits, we round it to 200. Rule number 3. If the number to the immediate right of the last significant digit is 5 and followed by a non-zero, we round it up. So for example, 78.657, 5 is followed by a 7. We need 3 significant figures, so we round up the 5 to 6, and then we have 78.66. Now we're using the previous rule, and we round it up to the value of. Rule number 4. If the number to the immediate right of the last significant is 5 and followed by a 0, you look at the last significant digit to make it even. It's kind of tricky. So when you have, for example, 2.5350, we need 3 significant figure. So simply you look at the 5, so it's followed by a 0, and you look at 3 now, you make the 3 to the next even number, which is 4. So let's have another example. We have 2.5250. We need 3 significant figure. Obviously this 5 followed by a 0, so we look at the last significant digit before 5 is already even number, is 2. We leave it as it is. If it were 3, we would have rounded to 4. So in this case, the value would be 2.52. Let's try these examples. So this number, we want to have 3 significant figure. Obviously, so 3 significant figure means we have to round this, and this is the last digit, so it would be obviously 201. Next, so we need 2 significant figures. So these 2 numbers, when you round it, we take them off, and the answer is 18. Next, we need 3 significant figures. Let's talk about the rule of 5. So we have 5 here. After the 5, we have obviously non-zero is 5. So, and then you have a 0 here. It's kind of tricky now. So we know that if this is 0, we look at the number before the 5. It's 5, and if you remember, we round it to the next even number. So the answer is 136. Next, we need 1 significant figure, obviously. In this case here, these 2 would be rounded, and this become 3. So the answer would be 0.003. Last one, we need 2 significant figures. So we have 5. Non-zero is more than 0, obviously. So we round these things to 0.6, and 0.6 would be rounded to the next digit, which become 99. Significant notation is used for representing very large or very small numbers. This is very common. Also, in your calculator would say scientific number. It consists of a number between 1 to 10, a digit, and then with 10 to an exponent. I'm sure you have seen that before. Let's just have some examples. Let's start with large numbers. If a number starts with greater than 1, obviously the exponent is positive. For example, 39,923, if you want to have the significant notation of that, obviously first you move the decimal to the first digits. So this is the value. So we have 1, 2, 3, 4, 5 significant figures here. And then you will see you have 4 digits here. So the value would be 10 to the power 4. So it would be 3.9923. We respect the same significant figures as here, as we have here, but the exponent is 10 to the power 4. I'm sure you have seen that before. Let's talk about the small numbers. So for example, 0.0052, if we need to have obviously the same number of significant figures, which is 2, so we simply move the decimal to this point. So now we have this 5.2, and 1, 2, 3 digits we have So it would be 5.2 10 to the power minus 123 minus 3, and the answer would be 5.2 10 to the minus 3. Let's go over a few examples. So first number, we move the decimal to this point, and obviously the answer will be 9.934 10 to the power 1. We moved the decimal only 1 point. Now we move decimal 1.23, so we go 3 decimals, and the answer would be 4.0001 10 to the power 3. Here now, we're moving the decimal to the right side, so 1, 2, 3, 4. So therefore, in this case, it will be 3.75 10 to the minus 4. Here, we move the decimal 1, 2. So it will be 2.34 10 to the power minus 2. And last, so we have a decimal here, we move it 1, 2, 3, 4. So we move the decimal 4 digits to the left side. So for that reason, it becomes 9.45771 10 to the power 4. Now, if you want to go from the scientific notation to ordinary or regular notation, is exactly the opposite of what we did. You start with the number and move the decimal the same number of the spaces as the exponent. Obviously, if the exponent is positive, the number is more than 1. If the exponent is negative, the number is less than 1. Now going back to ordinary notation from the scientific notation, pretty much the same. So I have some examples here. We have 3 10 to the power 6. Obviously the number is more than 1. You write 3 and 6 zeros. 6.26 10 to the power 9. So you have already, you can write 626. So we have 2 already digits added. And 9 minus 2 becomes 7, so it should be 627 zeros. This value obviously is less than 1, and you write 5. In total, the number of the decimal should be 4, therefore is 0.305. And 7.45 10 to the minus 7. So in this case, the answer should be 8. We write 845, and we have 6 zeros before 8. That makes total of 7 decimals after 8. 1, 2, 3, 4, 5, 6, 7. Last but not least, so you write 2.25. So you move the decimal already 2 digits. So you already added multiplied by 100. So you have 3 minus 2 become 1. So the answer will be 2250. So by a little practice, you will master converting from ordinary notation to scientific notation and vice versa. Let's talk about addition and subtraction as far as significant figures are concerned. The simple rule of thumb is we always go by the lowest number of significant figures. Here we have 3 sig figures, here we have 5. This is the final answer before getting to 3 significant figures. So 3 significant figures means we need this part, except the fact that this part has to be rounded. So 70 we rounded to 1 decimal on the back is 7. This 7 become 8, and these 2 become 0. So the final answer would be 59.8. Subtraction, we have 4 significant figures. We have 4 significant figures. Here we have 6 significant figures. Then we have to do the same thing. 51, we round 1 to 2, and the answer is 36 2.72. And last but not least, we have three significant figures. We have three significant figures. The final is four significant figures. We have to round. Remember the rounding rule. When we have a 5, the previous digit is even, so we leave it as it is. The final answer is 332. Multiplication and division also is very important when you are doing some calculation. Don't forget, you always go by the lowest significant figures. Here we have 4 significant figures, and here we have 3 significant figures. So the final answer should have 3 significant figures, means we need to have these 3, but obviously you have to round it, so in this case become 49.7. Here 3 significant figures, here 5 significant figures. The answer should be 3 significant figures. In this case, you look after the 4 is less than 5, so you round it down, and the answer is 46.4. We have 5 significant figures, we have 7 significant figures. This is the answer, and this answer already has 5 significant figures, so we leave it as is. So we have 5 significant figures here, 4 significant figures here, so this should have 4 significant figures, sorry. And in this case, so you want to get 4 significant figures, so what you do is you move this one to 1, 2, 3, 4. So this is what we need to do, and these are all less than because 1 is less than 5, so you cross that, and the answer would end up to be this. Last but not least, so here is Avogadro numbers. So 6.022 10 to the power 23, and the answer is 1. But let's see, 1, 2, 3, 4 significant figures here, 4 significant figures here. So the answer should have 4 significant figures, which is. Now let's talk about the mixed order of operation. We have one number add to the result of a multiplication of 2 numbers added to the third number. After simplifying, so we get this result. Bear in mind we have 4 significant figures. The result of this should be 4 significant figures, as you can see here, and then added to another number, so the final result should have 4 significant figures. So we need to round this number, which is actually this part. So the final answer is 239.6. The next one is addition of these 2 numbers multiplied by addition of these 2 numbers. Again, 4 significant figures in these 2, 4 significant figures and 5 significant figures. So the result is 4 significant figure multiplied by 4 significant figures. So this number has to have 4 significant figures, which is this here. So we have to round this section, and the final answer would be 2180.